Hello, good afternoon. This is Mr. Chu again. So back to our lessons where we are going to continue for semester 3 organic chemistry, where yesterday we discussed the chapter 3, which is about aromatic compound for the section A, which is the objective section. We are going to continue with section B, which is the structure questions for chapter 3. So without hesitation, let's begin our lesson. So let's have a look at the questions. Question number 1 sounds like this. Reaction scheme below shows the preparation of some reactions involving ethylbenzene. So you see here, you have benzene starting from A, you form ethylbenzene. Ethylbenzene react with chlorine under UV to form major X. Okay, and then you have another reaction also react with chlorine, but in AlCl3, you form a para-ethylchlorobenzene. Para-chloroethylbenzene, sorry, plus compound P. And then when you oxidize major X, okay, so it becomes benzoic acid plus colorless gas Y. A, state the reagent and condition required in A to prepare ethylbenzene from benzene. So these are very basic questions where in here you should have known by yourself that in order to prepare alkyl benzene, so you should use something with R Cl catalyzed by AlCl3. So depends on what type of alkyl that you want to use under reflux. So it depends on what alkyl. So since in here you want 2C, isn't it? So your alkyl must also have 2C. So your correct reagent will be CH3CH2Cl in AlCl3. Now there is also another alternative accepted answer in this case where you can use alkene. And when you use alkene, you must use phosphoric acid at 300 degrees Celsius. So this is the reagent condition that we accepted generally in STPM. Okay, so this is for question number A. Then B, chlorine react with ethylbenzene under different conditions to yield various products. 1. State the type of reaction in ethylbenzene react with the following reagent condition. Cl2 under UV. So now look carefully here. The question is looking for type of reaction. So if you answer chlorination, it's wrong. Chlorination is the name of the reaction. So when it is type of reaction, we are looking at either it is an addition, it is an elimination, it is a substitution, and then what is the substance that is added to the organic compound, or what is substituted to the organic compound. It may be a free radical, it may be a nucleophile, it may be an electrophile. So you have to give a full name for the type of reactions in here based on the substance, based on the categories that I have already highlighted just now. So in the case of Cl2 under UV, so it is no other than a free radical substitution reaction. And then Cl2 in AlCl3 is no other than electrophilic aromatic substitution reactions. Okay, so that is how you should answer for the type of reaction in 1. Then you also have to eventually draw out the structure for major X. So in major X, when you were undergoing this free radical substitution reaction, so it will substitute at the carbon with lesser number of hydrogen. So that will form as a major product. So at the end of the day, your major X is this compound. So you form a chloroethylbenzene. So this is how you are going to answer for number A and B. And then in the boxes provided, draw and explain the structure of the major compound X. So you have already drawn the X, so you need to explain why is it that you form at the secondary carbon, we call it. It is a secondary carbon because the secondary carbon's radicals are more stable. Okay, secondary radicals are more stable. So that is the 1 mark. Then number 3, name compound P. The already question says that name compound P that form together with ethylbenzene when react with Cl2 and AlCl3. So P is auto, or either you write 2 also can. Autochloroethylbenzene. Okay, so you have to follow according to the IUPAC naming system. So if you want to find out more about how to name IUPAC naming system, you can visit my YouTube for more information. Finally, C, benzoic acid formed when compound X react with an oxidizing agent under suitable condition and release a colorless gas Y along with the side product. State the suitable reagent and condition as oxidizing agent and name the gas Y in here. Now, if you look carefully at our structure, now our structure in here, you are made of this benzene with a CHCl, and then CH3. So you have 2 carbon. So no matter how long your carbon is, so at the end of the day, you still, when you oxidize, you form COH. So what will happen to the other C? All the other C will become carbon dioxide plus water. And what will happen to the Cl? Cl maybe it can react with it can react with hydrogen to form HCl and etc. But we don't really bother about that. So what is the most important part in these reactions is, you know that when it is a benzoic carbon, it can undergo oxidation and form benzoic acid. So that is how you should be able to write the reactions in here. So our reagent and condition is acidified potassium manganate under reflux. So the question says state. So in another word, you can also write as a formula. So you write a KMnO4 / H plus under reflux also can, no problem. You can write for this symbol also can. And then definitely gas Y is a carbon dioxide gas. Okay, so we are looking for a gas in here. So carbon dioxide is the gas. Okay, so that is for question number 1. Immediately we go to question number 2. The nitration of benzene occur in the following steps. So you have a benzene first react with the nitronium ion to form an intermediate, and then you finally form a nitrobenzene. Number 1, what reagent and condition are needed for this reaction? So in here you require, this is a very general and very basic question, so you must try your best to memorize this. It is by using concentrated nitric acid catalyzed by concentrated sulfuric acid. Both words concentrated must be there. Okay, both word concentrated must be there. So if you write just HNO3 and H2SO4, we are not going to accept that. Then number 2, write an equation showing how electrophile of NO2 is formed from the reagent. So you have to know by yourself the reaction between HNO3 and H2SO4 to form NO2. So this is the equation. HNO3 plus H2SO4 form NO2 plus HSO4 minus plus H2O. So in here, state of matter doesn't matter. If possible, write a reversible equation, reversible arrow. Even if you don't write, I don't think they really stress on that. But the most important thing is balance in here. And in here, you shall show on how the nitronium ion is formed. Okay. Number 3, fill the space with the structure of the intermediate formed during the nitration. So in here, you have to know by yourself that when the double bond attack the nitronium ion, okay, so the intermediate that is formed in here is this structure. So you form H and NO2. So one of because this is in between 2 carbon, this is a technique, this is between 2 carbon. So one of them takes the positive, another one takes the whole NO2. Okay, so in this case, this one takes the positive, this carbon takes the positive, this carbon takes the NO2. So at this moment, H is not yet eliminated, so the H must be there. So this changes from trigonal planar to become a tetrahedral structure. Then B, nitrobenzene form can be converted to aniline with which is the base reagent to synthesis dye in the textile industry. Complete the equation by filling in the suitable reagent and condition and the structure of the aniline in the boxes provided below. So structure SN and HCl, aniline is NH2. Okay, so very straightforward. Number 2, state the type of reaction occur in this process. So this is no longer electrophilic aromatic substitution reaction. Instead, from O2 become H2, it is obviously a reduction reaction. Okay, a reduction reaction. Number 3, state another use of aniline other than the color dye. So aniline can also be used as to form phenol in pharmaceutical industry, and that is one of the closest answer that we can get in here. Okay, so that is how you should answer for question number B. Then we have a look at question number 3. An unsaturated hydrocarbon X has the formula CaH8 burned in a smoky flame. Based on the description above, describe the structural formula of X. Now, this is a very this is a very common and important feature that you must know. If the ratio between C to H, in this case is 8 to 8, okay, which is approximately 1 to 1, guaranteed there will be a benzene ring inside them. So when you have a benzene ring, so this will be C6H6, isn't it? However, as you form bond, one of the H is replaced, so you form C6H5. So now you want to write CaH8, isn't it? You must have a 2C in between. Now this 2C can be here, can be also here. But if you put CH3, can you imagine? If you put, let's say, CH3, so this will become C6H4, this will become CH3, this will become CH3. So altogether will be C8H10. So which is not what we want. So it cannot be like this. So even if we put as alkyl lah, okay. Let's say you put as CH2, CH3 lah. Okay, so this is C6H5 and this is a C2H5. So it is also C8H10, isn't it? Okay, so no difference. In another word, it cannot be a saturated carbon. So what could C8H8 be? Now C8H8 is definitely unsaturated hydrocarbons of this one. So I draw it another space so you can see. So X is guaranteed unsaturated hydrocarbon on the benzene ring. So this is a very tricky part in here, but which you must know on your own. How should the structure looks like? If you go through my modules or you go through my YouTube video, I will definitely show you what are the formula that represents what. STPM student, you should at least know, if let's say if you have C8H8, it must be this structure. C7H6O, it must be aldehyde, benzaldehyde. If C8H8O, then it can be phenylethanol, it can be phenylethanol, so can. Then if you're looking for C8H10, C6H6O, then it is phenol. Okay, C7H6O2, benzoic acid. So these are all very basic formula that you all should know. Whenever I give you this formula, you should be able to draw out what is the possible structure with that formula. Okay. So why is this important? Because once your X is wrong, your A is wrong, sorry, then your B all will also be wrong because B use X as the fundamentals of questions. So X can decolorize bromine, which will eventually try to tell you that it contains alkene. Decolorize bromine to form various products under suitable conditions. X can also react with acidified potassium manganate to form carboxylic acid. In the table below, draw the structure of the product form and state the type of reaction when bromine is dissolved in the reagent stated. So X react with bromine in tetrachloromethane and bromine in iron 3 bromide. So the structure of the product when it is react with bromine in tetrachloromethane, you form dibromo alkane. But if you react with bromine in iron 3 product, this is a little bit tricky because not only that it can react with the double bond in here, it can also react with the aromatic in here. Okay, and teacher, can we accept auto position or not? We can usually we accept that because alkyl is auto para director, so shouldn't be much of a problem. Okay. But still, usually for habitual purposes, I write in the para position. Okay. So based on this, what is the type of reaction? So the first one is electrophilic addition reaction. Then the second one is electrophilic with electrophilic aromatic substitution reaction. So usually we don't write, give mark for the repeating answer. So we are looking for the electrophilic aromatic substitution reactions. Okay. So the bromine can still react with the C double bond C even though under the presence of iron 3 bromide. So you have to be very careful in this case because even without the organic solvent, bromine can still react with the C double bond C. Then we go to number 2. Write equation to show the reaction between hot concentrated acidified potassium manganate. So in here, when you X react with KMnO4 in H+, so we will form a carbon dioxide and also benzoic acid. The question already said that it forms carboxylic acid. Very straightforward question. Okay, then we go to question number 3. S can be polymerized to form a polymer which is widely used in packing industry. So the question said, draw 2 repeating unit of polymer form, okay, and state the type of polymerization. Okay, so the question state you ask for repeating unit only, so you shouldn't contain bracket n. And in here, for the latest STPM way, you must put a square bracket like this, square bracket like this. Okay, square bracket like this to show that it is a repeating unit and it's polymer. Okay. Okay, and what is the type of polymerization? This is additional polymerization. Additional polymerization. Okay, so this one you should be able to write out. Teacher, can I write additional addition polymerization? Cannot. If you write addition polymerization, it's not correct. Okay, so it must be strictly additional polymerization. Okay. Okay, so with that, that is for question number 3. Immediately we go to question number 4. Benzocaine is an important local anesthetic used in skin cream for sprain and other muscular pain. It can be made from the following route. You have methylbenzene, then you have then you add NO2, then you changes CH3 to become COH, NO2 to become NH2, and finally you become an ester. Okay, so that is the step-by-step mechanism. So suggest the reagent condition for each of the following. So this one you must know by yourself, please. You must really study the reagent condition to synthesize the following organic substance. For example, if you want to add from methylbenzene to become nitromethylbenzene or nitrotoluene, so you must use concentrated nitric acid catalyzed by concentrated sulfuric acid under reflux. Both word concentrated must be there. Okay. Then number two, it is obviously an oxidation. So you use any oxidizing agent, especially hot concentrated acidified potassium manganate under reflux. So can. And then number three, you NO2 become NH2. This is a reduction. So for reduction of NO2 to become NH2, then it is a thin in HCl. Thin in HCl. And finally, to become ester, okay, so this is eventually a carboxylic acid, but you shouldn't make it as an excuse because you already learned during your 445 last time. So in here, you form the ethyl benzoic acid, so it must be ethanol catalyzed by concentrated sulfuric acid under reflux. Okay, so this is the only answer that we have in here, no other answer other than all this. Okay. B, state the type of reaction for the following steps. So the step one is definitely electrophilic aromatic substitution reaction. And then number two is the type of oxidation reaction. And finally, number four, to become ester, it has a special type of reaction. We call it as a condensation reaction. Okay, condensation reaction. Okay, so this one you will eventually learn. So condensation reaction is when two organic compounds react together. You form a brand new organic compound with different functioning group and a small molecule as a side product. So that is for condensation reaction. Then we go for number 5. Benzene, toluene, and nitrobenzene each undergoes chlorination when react with iron 3 chloride. A, write the equation for the chlorination in nitrobenzene. Question already specifically said nitrobenzene, and you must know that NO2 inside the nitrobenzene is a meta director. So there is only one answer towards this. So I use chlorine. Sorry, I have to change to chlorine because the question said chlorine, and I made the mistakes in here. So hope that you all will pardon me. Didn't see clearly, sorry for that. It's my mistake. Okay, so you form chloronitrotoluene, Cl. So this side product is HCl. Okay. So that is for number 1. And then number 2, state the function it as a catalyst. And number 3, write the mechanism for the chlorination of the nitrobenzene. So can you hold on for a while? Okay, so number 3, write the mechanism for the chlorination of the nitrobenzene. So in here, the step-by-step mechanism starts with this. So try your best whenever you describe for one, try your best to write the type of reactions in here. So the type of reaction is a type of this electrophilic aromatic substitution reaction. Try that. Just write. Don't care where the marks are located. Okay, so the first step starting from how the Cl in here attacks the FeCl3 as the catalyst to form a complex of ClCl, FeCl3. Then the second step is in here, okay, where the pi electrons inside the benzene attacks the chlorine, the electrophile, and then a heterolytic fission takes place in here. So you form an intermediate of the Cl, HCl in here. So this, try your best to write the slow steps inside here, okay? And finally, the last step is the deprotonation. So the deprotonation is where the chlorine lone pair electron will attack the proton, and the proton will form back the double bonds to form the desired product in here. Okay, so and this is a fast step. So that is how you should step by step write the chlorinations in here. In the latest STPM way of proposing mechanism, we no longer accept this answer already. I see in some old syllabus, they still uses this half round and then this positive like this. So let's say if you want to write H and Cl, Okay, let's say it's like this. So this is no longer accepted in STPMs already. So you cannot draw like this. If you see anything in books, can you please ignore it? Okay. So that is how you're going to write for the mechanism for the chlorination of the nitrobenzene. Okay. Okay, and finally for number D, arrange the three compounds in this increasing order of reactivity towards chlorination. Explain your answer. So the increasing order is nitrobenzene, benzene, and toluene, 1 mark. So you have to say NO2 is a ring deactivate group which slow down the rate of reaction, while methyl group is an electron donating or activating group which will increase or speed up the rate of reactions in here. So very straightforward answers in here. Okay. Okay, so with that, that is for number 5. Then we go for number 6. Benzene sulfonic acid is an important reagent used mainly in the synthesis of a household detergent. The general equation can be written as follow. So you have a benzene react with X catalyst Y to form SO3H. So this one you must know by yourself what is reagent X and what is catalyst Y. So reagent X in here is sulfur trioxide, SO3. And because the question already said the keyword, so the keyword in here is name. So you must name the reagent. You cannot write formula. So please be careful with that. And the catalyst Y is concentrated sulfuric acid. Also must be written in the name. Okay. Okay, B, state the type of reaction when X react with benzene. It is a type of electrophilic aromatic substitution reactions. Okay. Okay, number 3, benzene sulfonic acid can be used to synthesize other useful product. A reaction scheme involving benzene sulfonic acid is shown below. So benzene sulfonic acid react with A to form a bromobenzene sulfuric acid, and react with B to form an intermediate C, and then your reagent D to form the COH SO3H, meta carboxyl sulfonic acid. Okay, so name the reagent and condition for A, B, and D. So in here, to add in bromine, you must require Br2 in FeCl Br3 under reflux, if possible. I forgot to write under reflux. Okay, so you must have under reflux. Whereas B in here, B is the you want to form COOH, okay? So it must be either a methylbenzene, chloromethane in AlCl3, or you can use Acyl chloride also can, okay? Or CH3COCl in AlCl3. Because at the end of the day, all of the D in here is the oxidizing agent, which is KMnO4/H plus under reflux, okay? And what is the structure of C? So structure of C depends. If you use CH3Cl in AlCl3, of course it's CH3 lah. But if you use a COCl in AlCl3, your intermediate product is C-double-bond-O-CH3. Okay, so it depends on what reagent and condition you give in B. So there will be 2 answers in here. Okay, I guess that is all for the discussion for the structure questions that I can share with you today. So if you like my video, please click the like buttons in here inside this YouTube. And if you want to receive further notification when I will share the video, so feel free to subscribe my video and click a like notification button to receive further information. Okay, so I guess that is all for our lesson today. So see you all tomorrow. Okay, goodbye.